In this video, I'm going to introduce you to a concept called limits. In layman's terms, if I have a limit for a function, it means that as I tend towards a particular value for x on that function, either from the left-hand side or from the right-hand side, I will reach the same height. So let's take a look and see, for example, what would the height that I would have reached if I had gone along this function, which happens to be a straight line, from the left when, say, x was 1. When x is going to be 1, and I tend towards x equals 1 from the left-hand side, I'm going to come along in this direction over here. As I come towards when x is 1 from the right-hand side, I'm going to come along over here. But let's see what I would have had if I'd actually had when x was 1. Well, when x is 1 is, for example, a value over here. And if I take a look from the left or from the right, when x is equal to 1, I'm going to arrive at the exact same height. Because I've got to the exact same height, a height when y is 2, I say that there is a limit on this function f of x equals x plus 1 when x is 1. But would I have had a limit on this function? Now this is a slightly more complicated looking function, and so we need to first take a look and see, is there any way that I can simplify this function before I draw it? Can you see that in the numerator you've got a difference of 2 squares? So in other words, this function is the function of x plus 1, x minus 1, all over x minus 1. Let's just change that color. And your x minus 1 factors cancel out. In other words, this function that I've drawn over here looks like the function that I had before of x plus 1. But what is different? In this function, I've got a restriction because I had a factor in my denominator, and before I remove that factor, I must note its restrictions. The restrictions are clearly that the x over here may not be equal to 1. Now let's check and see what's going to happen if I have a limit. If I have a limit, I'm going to do the same trick that I did before. I'm going to see what value I'm going to tend to as I approach x is equal to 1 from the left. As I approach x equals 1 from the left, I'm going to come along this part of the graph over here. As I come along my function from the right towards when x is going to be equal to 1, I arrive at the same height. Even though nothing exists when x is equal to 1, because there is a hole at x is equal to 1, I still arrive at the same height. In other words, I can say that there is a limit when x is equal to 1. This doesn't mean to say that f of 1 exists, because we can see that it does not, but there is definitely a limit as x tends to 1, and the limit is going to be 2. In this example, you can see I've not given you a picture of the curve. And so from this, we can see that we can actually still find out if a limit exists by just looking at the expression. Now on this function, which you don't know what it looks like at the moment, I want to know, is there a limit when x is tending towards 2? If there's going to be a limit when x is 2, it means that if I had drawn my finger along the curve from the left and from the right, I would have reached the exact same height. Let's take a look over here, though, what our problem is. Can you see that if I immediately took this little 2 and I substituted it into my denominator, I'm going to get a 0 denominator. Now that clearly is not allowed, because that gives me an undefined expression. So if I go back and I now take rather a look at my expression, and I first try and factorize it before I substitute in that x value, maybe that's going to help me. So if I factorize my expression, I still haven't found the limit. But you can see in the numerator there's a nice different trinomial factorizing that you can do. When you factorize that using the trinomial method, then you're going to get x plus 3 and x minus 2. Well, you can see before I've even finished writing this out that there's an x minus 2 factor in the numerator that can cancel with the x minus 2 factor in the denominator. So there's a removable problem. In other words, if I want to find this limit over here as x tends towards 2, I want to find it for the expression that remains after that problematic denominator was removed. If I now put in the value when x is 2, I'm going to get 2 plus 3. In other words, on this function, I am going to tend to a height of 5, whether I'd come from the left or from the right on this curve. Note, though, there is no continuity when x was 2, because that had to be removed, because I've got a restriction when x is equal to 2. So in this diagram, you would have found that there would have been an open circle or a hole at the point on the graph in line when x is going to be equal to 2.